Okay, we're going to divide radical expressions. So, quotient property of radicals says if you have a root of a quotient, you can split that root into the numerator and to the denominator. So, a really quick example, if I had square root of 4 over 25, we could rewrite that as a square root of 4 over the square root of 25, because then we can take both of those square roots easily on the numerator and denominator to get 2/5. Okay, so root 7 root 7 over 3. We can split into root 7 over root 3, but that doesn't get us anywhere because neither of those are perfect squares. And we can't have a square root in the denominator, so we're going to have to get rid of that square root in the denominator. In order to do that, we need to multiply by that radical. So we're going to multiply by root 3 on both the numerator and the denominator. We do that because square root of 3 times square root of 3 is square root of 9. And square root of 9 is a perfect square. So our denominator is now 3. We don't get rid of our denominator entirely, but at least it's now a coefficient, or excuse me, a constant and not a square root. And then the numerator, we just use our product property and multiply to get root 21. So our final answer would be root 21 over 3. Okay, here we have square root of 5, square root of 5 over x. So we can rewrite that as root 5 over root x. Again, we need to multiply by root x over root x. When we do that, we get a root 5x over x. And that's as simplified as we can go. Okay, square root of 72 x to the fourth over 3 root 20 x cubed. Lots going on here. We can split this into two parts. So we want to simplify before we go ahead and multiply. So root 36 root 2 root x to the fourth, and then the denominator would be 3 times root 4 root 5 root x squared root x. Remember, we want to get it into as many x squareds as we can, since the square root of x squared is just x. Okay, 6. The square root of x to the fourth is x squared, which is where I get the 6x squared, and then that root 2 on the numerator. The denominator simplifies to be 6x root 5x, because remember this is 2, so 3 times 2 is where I get the 6. Square root of x squared is x, which is where I get that x, and then we have the leftover 5x in the radical. Now we don't want that square root in the denominator, so we need to multiply by, I missed a step. We can simplify these 6's and the x's. So we would have an x root 2 left on top over just a square root of 5x. So always simplify as much as you can before you have to multiply by anything. It'll make your life easier. Now we're going to multiply by that root 5x over root 5x. The numerator becomes x root 10x over 5x. The last thing to do would be to cancel those x's, so we have a root 10x over 5 as our final. Okay, this one looks a little different. It's 3 over 4 plus root 5. We can't just multiply by root 5 over root 5 because we would have to distribute to the denominator and we would have a square root left over. So we're going to introduce something called a conjugate. The conjugate looks almost the same except for it has a different sign. So we have an a plus root b. Our conjugate would be a minus root b. So we would have to multiply by 4 minus root 5 over 4 minus root 5. We're going to distribute, so the numerator would be 12 minus 3 root 5. The denominator needs to be FOILed, so our firsts would be 16. Outsides would be minus 4 root 5. Insides are plus 4 root 5. And then the lasts would be minus a root 25. These middle two terms will always cancel off, so when you multiply by the conjugate, it's okay to multiply just the firsts and the lasts. So we're left with a 16 minus a 5 on the denominator, because square root of 25 is 5. And then just simplify that as 12 minus 3 root 5 over 11. You cannot combine these 12 and these 3 because that 3 is attached to the 5. So it has to stay 12 minus 3 root 5. And I would like you guys to simplify 2 over root 3 plus 1.